I have just received the last lithium iron phosphate battery, 12.8 volt, 300 ampere hours, and I'm quite disappointed. I will explain to you why. In the advertisement for the 12.8 volt, 300 ampere hour battery, it says very clearly that it has a capacity of 300 ampere hours. This is a screenshot where it definitely states that the nominal voltage is 12.8 volt and the nominal capacity is 300 ampere hours. I have tested the PFDD 12 volt 300 ampere hour battery. I've done a discharge test, and the discharge test showed me that there is only 60 ampere hours in the battery available. Probably not even that much. I have charged the battery and it only took up less than 69 ampere hours. I have weighed the battery and the battery weighs 7.1 kilogram, which is the same weight as a 60 ampere hour 12.8 volt battery. These tests mean that I have received a 12.8 volt 60 ampere hour battery and not a 12.8 volt 300 ampere hour battery. As you can see from the shipping label, the company itself claims that the weight of the contents is 7 kilograms. The packet itself weighed 8.5 kilograms, and when you take the battery out, the battery itself weighs 7.1 kilograms. When you look on the web, you will find that a typical 60 ampere hours 12.8 volt battery weighs 7.2 kilograms. So 7.1 is about the right weight for a 60 ampere hour battery. A 100 ampere hour lithium battery with 12.8 volt would weigh 11.1 kilogram. This is nowhere near 11.1 kilogram. A 3 times bigger capacity, like 300 ampere hours, like I was promised, would actually weigh 3 times more, which is 33.3 kilogram. So a 12.8 volt 100 ampere hour battery weighs about 11.1 kilogram. A 12.8 volt 60 ampere hour weighs about 7.2 kilogram, and a 300 ampere hour battery should weigh 33.3 kilogram, but the PFDD 12 volt 300 ampere hours weighs only 7.1 kilogram, the same as a 60 ampere hour battery. So the PFDD 12 volt 300 ampere hours is actually a 60 ampere hour battery. In case there is still a doubt, I have carried out 2 experiments. I have fully charged the battery up to 14.7 volts, because that's the voltage that comes out of the power supply that has been supplied together with the battery. I have used this setup to draw a current of about 9 ampere. As you can see, I'm measuring this with the ampere meter. I then measured how long the battery can supply a current for to determine the number of ampere hours. And this is the result. First, the voltage goes down from 14.7 to 13.2 volt without any current flowing. I then connected the battery up to the discharge circuit. A more or less constant current was provided for a bit more than 6 hours. So a current of 9 ampere for a time of a bit more than 6 hours gives, at 12.8 volt, about a capacity of 58 ampere hours. Okay, let's be generous, let's say 60 ampere hours. So the discharge capacity suggests that I've got a 60 ampere hour battery, not a 300 ampere hour battery. To make doubly sure, I've made another experiment where I measured the battery charge capacity, that means how much charge is actually going into the battery. And the result of this was that I managed to get less than 70 ampere hours into the battery. Again, this suggests that this is not a 300 ampere hour battery at all. So in summary, I have tested the PFDD 12 volt 300 ampere hour batteries that I received, and I have tested the discharge, and it provided less than 60 ampere hours. It should have provided 300 ampere hours. I've charged it and it should have charged at 300 ampere hours, but no, it only charged with less than 69 ampere hours. And the weight should have been 33 kilograms, but no, it was 7.1 kilograms. So in summary, I received the wrong product. I received a 12.8 volt 60 ampere hour battery, and I was promised a 12.8 volt 300 ampere hour battery.